what we call KW and pH. That is today's lesson, KW and pH. And here's the idea, starting off with KW. Hopefully you guys have kind of guessed that acids and bases are very much related. They are the two halves of water. We kind of talked about that the last couple of days. H plus OH negative, when they're equal, you have pure water. When you have more H pluses, you have an acid. When you have more OH negatives, it's hydroxide ion, you have a base. Well, as it turns out, they're even more related than that. They are inversely related. And when you multiply them together, you will always get the same number. It's a constant, and that's what we call the KW. And KW has a value, at least at certain temperatures. KW is 1.0 times 10 to the negative 14th. So because we have this constant and because we know that the concentration of H plus times the concentration of OH negative, because they equal that constant, that allows us to always be able to find one if we have the other. Quick example. So if the hydrogen ion concentration, did we talk last week about how those brackets, when we put those brackets around something, it means concentration of? We talked about that? If we didn't, when we put those brackets around something, it means it's a concentration of. So concentration of hydrogen ions, which is equivalent of saying the concentration of our acid is 1.0 times 10 to the negative second molar. Is the solution acidic, basic, or neutral? Then there's a follow-up question. And I'll be honest, a lot of times it's easier to answer that follow-up question first and then go back and determine whether you're working with an acid, base, or neutral. Remember, the whole idea is if there's more H pluses, you have an acid. If there's more OH negatives, you have a base. So let's figure out, we know how many H pluses we have. We know what our hydrogen ion concentration is. Let's figure out our hydroxide ion concentration. Then we can compare the two, figure out which one's more, and determine whether we have an acid, base, or a neutral solution. All right, well, here's a formula. Guys, get in the habit of isolating your variables first. Don't just plug in numbers. That gets confusing sometimes. You kind of forget what numbers doing what, where, when, and why. So get in the habit of isolating your variables. We're looking for the hydroxide ion concentration. That's what we want. We know the KW, that's a constant, that's always this number here. And the problem gave us our H plus concentration. So we need to put our hydroxide ion concentration aside by itself. If these two multiply, the opposite of multiply is divide. So I'm going to divide both sides by H plus concentration, and that will give me my hydroxide ion concentration. That's the strategy for this one. Now that we have our variable all on the side by itself, we're ready to solve for it. So now we can go back in and start plugging in our numbers. We know our KW. Oops, that's my H plus concentration from the problem. KW was up here. And we know our H plus concentration, that's this one here. So when I divide those two values, or divide the H plus value out of the KW value, I'll end up with my hydroxide ion concentration. So let's get out our calculators. I'll see how that works. Guys, great opportunity. Type this in as I type it in. And that way you can see if you're doing it right or wrong. I think some of you guys are setting your problems up correctly. You're just making mistakes with your calculators. So plug it in, make sure you're getting the right value. Again, if you're doing your homework, you have no idea whether or not you get the right value because I'm not there telling you what the answer should be. So I'm going to use big E for this. Instead of hitting times 10, I'm going to hit the big E button on my calculator. We talked about it first semester. Really helpful. First of all, it saves me keystrokes. It's actually going to be simpler to do it this way. Saves me keystrokes, save me time. Second of all, I don't have to worry about order of operations, which the calculator might kind of trip up if you're putting 1.0 times 10 up to the 14th divided by 1.0 times 10 to the negative second. Your calculator might get all that out of order. So use the big E button, 1.0. To get to the big E button, there it is. It's above this X negative 1. See how it's in yellow and it's above? In order to get to it, we have to hit second. Second gives us all the yellow functions in the calculator. Yours might be blue or white or whatever color your second button is. Gonna hit that button right there and I get that big E. Notice that? That big E is the equivalent of times 10 up to the. So I just hit like 4 different numbers right there. Times, 1, 0, caret. And now I just put negative 14. So 1.0, big E negative 14. There's no time symbol. There's no 10. It's saving keystrokes. And then I hit divided by. And I'm pretty much going to do the same thing on the bottom. 1.0, second big E, negative 2. Press the compute button, and there we go. We have to be a little bit smarter than our calculator, though. We have 2 significant digits. Our calculator is only reporting 1. So my final answer here. I need 2 significant digits. Oh, there we go. There we go. Everybody get that? Does anybody have like a different calculator? I had a lot of people with Casios yesterday. Guess there's a popular new Casio out there, and you guys have different buttons. Yeah, for the Casio, I wouldn't hit the big E. Down at the bottom, kind of in the middle, if you have one of the Casios, there's a button that says times 10 up to the.
Oh, yeah.
I would use that button in place of big E, but the same exact thing. You don't have to hit times. You don't have to hit caret. Lauren, what kind of calculator do you have?
Did you say me?
Oh, there you go. Yep, TI. like this. One of the big ones. Can I borrow that? Oh, yeah, the TI-30X. That's this one. Somebody have, thanks, Chelsea. Somebody have this type of calculator? This one's a little bit bigger, but it works pretty much the exact same way. There's the big E button. Again, you have to hit the second. Yours is blue here. You have to hit that second to get the big E button. But double check. If you're not getting the same answer I did, double check. This is Chelsea's work. Guys, there's no time symbol. I don't put 1.0 times big E. There's no 10. It's just 1.0 big E. So make sure, again, go back, look at your work on your calculator. See if you have this exact order, 1.0 big E negative 14 divided by 1.0 big E negative 2. So you can always kind of try it again. See if maybe you just hit the wrong button. Thanks, Chelsea. Getting your workout in today.
Thank you.
All right, well, if you're still having calculator issues, let's take a look at that. Let's get through the rest of these notes. So come back and take a look at that. Next part of the question here, though, now that we have our OH negative and we have our H plus, is this an acid, a base, or neutral? I can't tell if you guys don't like the big negative exponents or if you're just being quiet because you're being quiet. Do you know why? Awesome. Yep, there are more H pluses than there are OH negatives. So this is definitely acidic. For those of you not quite seeing that, let's take a look. Let's take a look. I actually like doing this anyway. Sometimes it helps just to not write it in scientific notation. We're using the times 10 to the negative 2, times 10 to the negative 12. If we write this in standard notation, so here's our concentration of H pluses. In standard notation, 1.0 times 10 to the negative second would be 0.010 molar H plus. That exponent is just telling you how far, in this case, behind the decimal point we are, because it's negative. So it's telling us how far to the right of the decimal point we are. You guys are usually pretty good with positive exponents. You know, like if I say 10 squared, everybody says, oh, 100. You're 2 places out in front of the decimal place. If I say 10 to the third, you guys say, oh, 1,000. Because you're 3 places out in front of the decimal place. Well, these negative exponents are the same exact thing, except, again, because they're negative, all we're doing is moving behind the decimal. We're 2 places behind the decimal. That's all that's saying. That negative 2 is telling us, hey, here's the decimal, and our number is 2 places behind it. Same thing. With our concentration of hydroxide ion. 10 to the negative 12 is telling me that we're 12 places behind the decimal. Pretty easy way to do it. Whatever your negative exponent is, just take 1 less than that number. So 12, 1 less than 12 is 11, and add 11 zeros between your number and the decimal. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Woo! So there's our concentration of hydroxide ions. Hey, now it's sometimes easier to see. I know a lot of times you guys don't like the negative exponents, but which of these two numbers is larger? The H plus concentration or the hydroxide ion concentration? Yeah. Yeah, our H plus is way bigger than our OH negative, way bigger. I mean, it's 10 to the 10th times bigger. 10 to the 9th is a billion, so we're talking about 10 billion times bigger. 10 billion times bigger. So yes, this would be an acidic solution. Absolutely. Questions on that concept so far? All right. Let's moving on then. Moving up, moving on. Let's take a look at pH. Some of you guys may have already worked with this. You might not be happy. I think many of you guys have not worked with these before, and that's fine. They're not bad. If you're not happy with them from previous times, guys, don't sweat it. It's not nearly as bad as it looks. We calculate pH. Nope. We calculate the pH. And if you remember, pH stands basically for your potential of hydrogen ions. So how strong is your solution with hydrogen ions? We calculate this by finding the negative log of H plus. This word log stands for logarithm. And some of you guys may have worked with it in your math class already. Some of you guys may not have. It's all right. Don't sweat it. It's actually not nearly as bad as you might think, a logarithm. Ten to the power of something, in this case, 10 to the x. Guess what? That x, that's a log. That's all this is. We're trying to figure out how far behind the decimal our numbers are. Now, again, because it's a negative log, we're looking for a negative exponent. But that guys, that's all a logarithm is. It's not terribly complicated. We're just trying to figure out, again, how many times behind the decimal are we? Here, we'll do some in our head. Don't even need a calculator for this. So let's say we have a 0.1 molar HCl solution. If I were to put this in scientific notation, I imagine you guys can all probably do this in your head. .10 molar would be the same as 1.0 times 10 to the negative 1. We're one place behind the decimal. Any thoughts what the pH of this would be? Again, a pH is just a log. A log is just the exponent behind 10. Chelsea? Yep, it would. Yeah, we're just one place behind the decimal, so our pH is 1. Now, this is kind of important. Actually, it's not terribly important because it's a weird year, and I'm not going to be too particular with it. But significant digits. This number here has 2 significant digits. This number here has 2 significant digits. This number here has 2 significant digits. Weird. It takes a little practice. But a pH The number in front of the decimal on a pH is not significant. That number is only telling us how far behind the decimal we are. That's it. It's not actually a measured or a counted number. It's just telling us how far behind the decimal. So whatever you have on your pH, whatever is before the decimal point, does not count as a significant digit. It's not really a measured amount. Hey, let's do another one. Let's say 0.010 molar HCl. Again, this time we are 2 numbers behind the decimal. What do you think the pH is? Yep. Hey, look at that. You guys doing logarithms in your head. They're not that bad. You are calculating logarithms in your head. Don't worry about them. If you've had a bad experience with them before, don't sweat them. They're really not that bad. Hey, let's try another one. One more. Actually, I didn't give any of my other classes this one. But you guys, I think, can handle this one. This one's interesting, all right? This is going to be a little concept bender here. I might need 2 lines. I have a lot of zeros in this one. Let's see if we can calculate the pH for this one. It's a trick. It's a trick. So let's see, how many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So that means we're 1.0 times 10 to the negative 10th molar HCl. I just warned you it's a trick, so more than likely no one's going to give us a shot at this, are they? Anybody want to take a guess? I didn't think so. Shouldn't have warned you guys there's a trick. You guys ready for a little concept? What is HCl? All right, let's back up a step. HCl, an acid or a base? Yeah, I think we all hopefully can identify HCl as an acid. Look, a little H in front of it there. It's going to donate that H. It's going to get rid of that H. So it's definitely an acid, definitely an acid. Okay, now let's think about what we know about the pH scale. Below 7 is an acid. These two are definitely acids. Actually, I should probably put 0 there to get my correct number of significant digits there. What is above 7? What's that? Bases. Yeah. So here's the concept. We have a really, really dilute acid. It's a very small concentration of acid. Very small concentration of acid. But what you'd be telling me if you reported a pH of 10, you'd be telling me that this acid is so dilute, it actually turns into a base, which is just ridiculous. Like the more dilute the acid, the more dilute you make that acid, the more basic it becomes. Imagine if there were 14 zeros. You'd call it the strongest base in the world when it's really an acid. So if you ever have an acid, you know you're working with an acid. And guys, you should know when you're working with an acid. You should know, right? They always start with an H. You should know when you're working with an acid. Don't ever go above 7. Even if you have like a really, really, really high exponent there, don't go above 7. All this is saying is that it's so dilute, it's not making a difference in water. I could put this acid into water and it wouldn't change it from water. It's just too dilute. So that's all that's saying. Watch out for that though. If you have an acid, don't ever go above 7. Just because it's a really dilute version of the acid doesn't make it a stronger and stronger base. So concept that gets people all the time. Hopefully it works for you guys. Let's take a look at a slightly more complex one. When you're working with ones, they're pretty easy. When you have any number other than 1, it gets a little bit more complex, but that's okay. It's what we have our calculator for. Again, in scientific notation, this would be 5.0 times 10. Let's say there's 2 zeros. So I'm going to say 10 to the negative third. However many zeros between your number and the decimal, add 1 more. There we go, 10 to the negative third molar HCl. All right, pH of this one. This time we're going to use calculator. I can't do this in my head. We could do some of them in our head. I can't do all of them in my head. You guys are welcome to try. So for this one, we need to use that formula we discussed. Here's how we do it. Negative. So make sure you guys are watching out. Negative is down here. It's in the parentheses. No matter where it's at in your calculator, it's probably in parentheses. But negative, and then here's my log button right here under second. So I hit that and it says log. Wes, if I'm remembering correctly, your log button is kind of towards the right side. Mm-hmm. Yeah, that's right. You found it? Good. Good. All right, now I'm going to go ahead and enter my 5.0, big E negative 3. Close up those parentheses, hit enter, and voila. If you guys got a different number, you probably got the same number. Let me show you. If I hit second and then the button right next to it, Sci Engineering, I can go over to flow, which most of you guys are probably in, and then I get my flow number. So again, if you ever want your number in scientific notation, second, go over to Sci, hit enter. And scientific notation right there. Oh, this, yep, same exact thing. Yep, same exact thing. So our pH, hey, we've got 2 significant digits. 2 significant digits. We only start counting the digits after a decimal on a pH, so 0.30. Jordan asked, do you have to put in scientific notation? Absolutely not. Same exact answer. Hey, Caden, Emma, Morrow, I didn't see you guys in the camera. Make sure you guys tilt those screens, get yourself in the camera. All right, let's go the other way. I give you the pH. You have to solve for the hydrogen ion concentration. What if we do it this way? Again, a pH is just a negative exponent on 10, base 10. So formula is just 10 to the power of negative pH. Not a whole lot to it. So to solve for our H plus, we say 10 negative 6.2. On our calculator, you can use big E if you want to. Just hit second, big E, negative 6.2. I'm going to use caret button, so I type in 10, caret, So this little, looks like the top of a caret right there. That gives me to the power of, and then I hit my negative 6.2. Hit enter, and there we go. Hey, watch out for that exponent right there. Again, you guys might be working in just normal standard notation. Get this. I prefer scientific notation. Look how many significant digits we have. Only 3, right? Looks like your value only has 3. Well, guess what? It has a lot more numbers on it. So this is a lot more precise value if you work with scientific notations. That's why I like it. But you got to watch out for that times 10 to the negative 7 there at the end. .2 pH. That's only 1 significant digit. Remember, we only start counting after the decimal. That 6 is just telling us how far behind the decimal we are. So 6, there's my 1 significant digit, times 10 to the negative 7th. Oops. I need this. There we go. Questions? My calculator showed me that 10 to the negative 7th. What value did you get? No, I have it, but yeah, and I'll be honest, I sometimes forget about that too. But I mean, good way to check your answer. We know if we're working with a pH of negative 6.2, that we're at least 6 places behind the decimal. And that's what that pH is telling us. We are 6 places behind the decimal. As it turns out, we're actually 7 places behind the decimal because it's more than 6, 6.2. We're not all the way to 7.0, but yeah, that's what that's telling us. Cool. All right, let's do one more example. I think you guys have some problems like this on your homework tonight. Watch out for this one. They're asking for the hydroxide ion concentration. Hydroxide ion, that is the OH negative one. That's what we're looking for. We're given a pH, but here's the thing, guys, we have to recognize that when we use that pH formula worked up here, here's a pH formula. When we use that, we got an H plus, not an OH negative. So we're going to have to actually do 2 steps here. First, we're going to have to use our pH to solve for H plus. Then we're going to have to remember that first formula we learned and use our H plus to solve for OH negative. So this one has 2 steps to it. So kind of plan out your attack before we go. All right, again, first step, solve for the H plus. (10 up to the power of negative pH gives my H plus. So again, with the calculators, plug this in, guys. Just make sure you're getting the same number as I am. Good chance to practice. So 10 up to the power of negative 4.57. I'm getting an H plus of 2.6915348 times 10 to the negative ninth. Significant digits. We only have 2, but this isn't our final answer. Remember, my final answer should be the hydroxide ions. So because this isn't my final answer, I'm not just going to record the 2 significant digits. I'm going to carry at least 2 extra. That's the general rule. So 2.6, those are my 2 significant digits. Then I'm going to go 9, 2. That 5 after the 1 is enough to round up, but I'm going to underline them to show that they aren't significant. I want to keep them. I don't want to round them off just yet. I might have what we call round off error if I do, but I'm going to underline them to show that they are not significant. So there is my molarity of H plus. Well, I did it again. Oh boy, sorry. I forgot that times 10 to the negative 5th there at the end. Ugh. Makes a pretty big deal. Okay, now that we have our H plus, now we can use that first formula that we learned today. To solve for our hydroxide ion. And we want to get hydroxide ion on a side by itself. The opposite of multiplication is division. So we'll divide both sides by H plus to get our OH negative. Now that we have what we're looking for on a side by itself, now we can plug in our variables and get ready to solve. So our Kw, again, that's a constant. That's always 1 times 10 to the negative 14th. The unit on that is molar squared. It's an invented unit just to make sure the math makes sense. And then we're going to divide that by our H plus, which is what we calculated over here. Again, let's use those calculators. Use them with me. Get the practice in. 1.0 second big E. Negative 14 divided by, and I make sure I underline those extra digits there, 2.692 second big E, negative 5. Hit the enter sign. There we go. Now I can round to my 2 significant digits. This one will be my final answer. The number after 7 is not big enough to round up, so we're just going to keep it at 3.7 molar OH negative. Wes? Oh my goodness, I did it again. Hang on. I'm sorry, Wes. I did it again. Forgot that times 10 to the negative 10th. Man, I am losing points all over today. Ugh. Ah. All right. Sorry about that. Go ahead, Wes.
I did everything I normally did last problem. And I got 3.4246.
You bring a calculator here.
Yeah.
Wow. All right, try it again. I just accidentally deleted it. Hitting buttons when I shouldn't be.
Oh, yeah, I got it.
Yeah, awesome. Probably just a miscalc the first time, you just hit the wrong button at some point, which is what I was gonna look for before I accidentally deleted everything. All right, well, people at home, questions? I see some of you guys are asking about the calculator. Yeah, don't stick around. But yeah, we're gonna take a look at your calculators in just a second. But any questions over the concepts or what we're doing here? All right. Fantastic.